All right, so besides looking at the rate of change being, just looking at the time being the x coordinate and then the y being the population, we can also look at a rate of change between 2 points. So just like in the last video, this is going to be a little bit of review and practice. You can have 2 points, like 2 and -3 and 4 and 5, and then you label your points x1, y1 for the first point, and the second point you label it x2, y2. And then you plug it in. So whatever value the y1 goes here, substitutes here, the y2 substitutes there, and you substitute it in and then you simplify. So we're going to go through practicing this, finding the rate of change, the differences between the y's and the differences between the x's with some coordinates. So I'm going to do one and then you do one, and if you need my help, you call me and we'll work one-on-one with the second one, okay? So graph the line through the points -3 and 1. So we have to first plot that point. -3 is to the left. So this is my x-axis. This is my y-axis, right? So -3 is going 3 to the left. So starting at 0, 0, when you plot a point, you gotta go 1, 2, 3 to the left, and then I got a +1. My +1. So I'm going to go 3 to the left, 1, 2, 3, up, 1. So here's my first point, -3, 1. Then I'm going to plot my second point right here. We got 2, -4. Well, start off, here's my x, here's my y. So we're going to start off with the x to the right. It's +2, so we're going to the right. 1, 2. And then -4, we're going to go down. So you go down. 1, 2, 3, 4. So we did this at the beginning of the year, right? And Euclid says the distance between 2 points is a straight line. So we can use our ruler and we can plot our straight line, okay? Now, right away looking at that, reading it from left to right, we know that this slope, this m, is going to be negative, right? So we can find that by taking the change of y over the change of x using this equation in the front. Right here, that's written nicely for us. So, to make things easier, and I know a lot of you are going to say, I know, I don't need to do that, but write down your x1, y1, and label your x2, y2. I do it still. I've been teaching this for like 11 years, and I still just write it down. It keeps everything nice and organized. So right here, I'm going to plug it into this equation. Well, my y2 is -4 minus my y1, right? My y1 is 1 divided by, so they got that bar for us right there, divided by my x2. By labeling it, I know it's going to be right over 2. So I'm going to put that in, minus the difference of the, so minus difference, right? Same meaning. x1. So my x1 is -3. So now use your calculator, use your head, check yourself with the calculator, but I owe you 4 minus 1 more, I owe you 5, right? 2 minus -3. So remember how we spent time? This is why we spent time talking about a minus negative. So two signs together, it changes to a positive, right? So we spent so much time doing that, so you'd be ready for doing this stuff. 2 plus 3, 5. Okay? So I plugged it into my formula, substituted it into my formula. Now I simplified at the top, simplified the bottom. Now I got -5 divided by 5. What is -5 divided by 5? -1. So my slope is -1, or I'm going to go down 5, run 5. So rise down 5, because it's negative. I'm rising down 5 and running over 5. So, or I can put a 1 under there, under my slope. It doesn't change much. But I got my down 1 over 1. Down 1, my rate of change is changing as I go from point to point. Down 1 over 1. Down 1 over 1. Alright, so my slope is -1. Or that's my rate of change. Down 1 over 1. So you're going to try this one. Just try it out. If you're struggling, call me over and we'll work it through together. All right? If you call me over to help you on this, at least I know you watched the video because you have that one done, right? So let's look down here. So again, slope, rise over run. That's our change, our y change over our x change, right? So what happens when I have a slope, a point, and then given the slope? So this is my rise 1, run 4. So 1, rise 1, run 4. Rise over run. We can use our rise over run to help us plot. So first plot the point, -2. So here's my, on the y, so, -2, plot the point like you normally would. Plot the point like you normally would. So -2, 1, 2, up 1. And then we're going to do a rise over run. So I'm going to rise from that point. I'm going to rise 1, because that's the top. The top is our rise. The bottom is our run. So I'm going to rise 1. Then I'm going to run 4. 1, 2, 3, 4. Rise 1, run 4. 1, 2, 3, 4. Rise 1, run 4. 1, 2, 3, 4. So then I can connect all those dots, and I got a nice line. Oh, that's not so nice right there. There we go. All right, so now you try this one. Plot your 3. 1, 2, 3, -5. 1, 2, 3, 4, 5. And try going down 1 over 3, down 1 over 3, down 1 over 3, and connect your dots. Okay? Or you could go up 1 to the left 3. So if you wanted to go opposite, you could go up 1 over 3, up 1 over 3, up 1 over 3. Or we could go down 1 over 3, down 1 over 3. All right? If you need help with those, let me know. All right? And then on the back, all right, we can talk about 5 different ways we can describe our slope. So we talked about it as a rate of change over time, how something changes, how like population changes over time. We talked about it as a rise over run. We talked about it as a change of y over a change of x, which I wrote over here in this space. So the difference of y's over the difference of x gives us our slope. Slope can be positive, negative, or even 0. Okay? So right here, you're going to work through some practice, but I just want to talk about how you can find the rise over run working backwards. So if this is my point, my point's right here, right? Well, I'm rising down, so rising down is negative, right? Rising down 5 and running to the right 4. So rising down 5, right 4. Here, I'm going up 4, right? So I'm going to be going up 4 to the right 4. All right? So 4 over 4. And then here we got our down 5 to the right 3. So down 5 to the right 3. Always start from the point at the top. All right? Or the point on the left. Start with the point on the left. That would be the best. Start with the point on the left. So this is my point on the left. This is my point on the left, point on the left. All right? And we'll have some practice with that. So here you're going to have to use this equation, y2 minus y1 over x2 minus x1. All right? And label your x1, y1, x2, y2. Okay? x1, y1. Label it and plug it in, and then you'll be able to solve for all those. If you need help, call me over. All right? And then go ahead and describe how you would walk this line. Okay? So they started off, finish off this little sentence here. Okay? And then as we move along, all right, find the slope for each of the given lines. So right here, my slope, remember, is rise over run. So rise over run, the rise 6, run 2, my slope simplified would be 3, or 3 over 1, right? Rising up 3 over 1, rising up 3 over 1, okay? And then at the bottom, you're going to label your x1, y1 for the first point, x2, y2 for the second point, and then you're going to want to plug it into this formula, y2 minus y1, changes of the y's over the changes in the x, right? And that'll help you find your slope, your m. So as you work through this packet, you're going to be practicing defining your slope, finding the slopes. You're going to have some real life examples. Call me over as you work through this packet, and we can talk about slope. All right, good luck. Talk to you later.